Okay, so hey everyone, today we'll be discussing the next question of our DP sheet, which is King Bombee. Let's read the problem statement. So here you have been given a simple undirected graph with n vertices and m edges. The vertices are numbered from 1 to n and the edges are numbered from 1 to m. Edge I connects vertices ui and vi, right? Okay, and here you have been given integers k, s, t and x. We need to find how many sequences a0 to ak are there which satisfy the following conditions. The first is that AI should be between 1 and n, A0 is S, AK is T, and there's an edge between AI and AI plus 1. And you have been given an integer x, which appears even number of times in the sequence. And since the answer can be large, we need to print modulo this number. So, okay, first of all, let's understand the problem better. Okay, so here you have been given. Let's understand what these conditions mean first of all. So since this is a sequence of length ak plus 1, this just means that since A0 is S and AK is T, you need to start from S, end at T, and you might take any node, any path, right? Either you may take this path or so on. And the path distance, path length, or the number of edges should be equal to K. And okay, now let me just increase the font size. So this length needs to be K, and a edge between AI and AI plus just means that you're just say consider this a graph. Just you need to traverse from S to T, reach T along some combination of nodes. Okay, and the length of the path needs to be K. And say the nodes which come in the sequence are say A1, A2, A3, and so on, right? Then the integer x needs to occur even number of times, right? It need to appear even number of times. So I hope the question is clear, and here you have been given n, m, and k are up till 2000, and same is s, t, and x. So yeah. Now let's dive into the solution. And another condition given is that x is not equal to s and x is not equal to t. Okay. So let's try to think of a solution. So the problem is quite simple right now. You have been given s, you have been given t. You need to reach by following some path, right? And so on. And the path length needs to be equal to k, right? Basically, you need to take k edges. And the parity of x, basically x should occur even number of times. Okay, so I hope the question is clear. Now let's think of a solution. Okay, so let's define our DP state as follows. DP of distance, comma node, comma parity, right? These are the three parameters which we need to consider, right? So this will store just the number of ways modulo, right? And so this DP state just means that starting from, it just stores the number of ways starting from node reaching T, and the distance required to reach node from S is dist, right? So, and the parity of occurrence of X is stored here, right? So if X occurs even number of times, then it will be 0, else it will be 1. So I hope the DP states are clear. This just means that DP of distance comma node comma parity says that the number of ways to reach from node to the end, which is t, and the distance required to reach from S to node was this, right? Now coming to the transitions and stuff, you might think this is quite a easy approach and a basic DFS, which I must say. So say I have calculated dp of I comma j comma k, right? Now since I'm traversing the graph, so I'll look for all x which are in the adjacency list of I, right? Adjacency list of j, and simply from here you're moving here, right? So now the distance increases because earlier you were j and now you're traversing all the adjacents of j, right? So the distance first of all increases by 1, and now you reach uh let's denote this by, I say, let's say v, right? So you were j and you were, say, this is v1 v2, and you're traversing the adjacent of j, right? So now you have reached v, right? And now you need to find the further way to reach from v to t, and the parity we can update as follows. Simply what I can say is, a smarter way to write this will be, if you can definitely use some if else conditions. A smarter way is just old parity XOR, and if v equals x, if it is, so simply say the parity was 1 earlier, right? And now again v equals x, this again returns 1, and since the parity was odd and now you have again found another x, the parity should become even, right? And similarly, if it was not equal, if v was not equal to x and the parity remains the same, right? 1 XOR 0 again remains same, because up till now x was still occurred odd number of times and x hasn't occurred now. So again the parity doesn't change. So the transitions were quite simple, right? Say I've calculated for dp of I comma j comma k. Now I'll traverse the adjacency of j, right? And say we denote it by v. Right, now I'll be traversing the adjacents of v, say v1, v2, other vertices. And what was dp of I comma j comma k? K was just a parity of x. And here j was, we have reached from s to j, and now we need to go till here, right, to t. And the distance to reach from s to j is stored in I, right? And so now we have moved one step ahead. So distance increases by 1. And now instead of j, we have reached v, right? So again this, and we just update the parity. So this is quite a simple code, a basic DFS, and we can just store it in a DP array to memorize the solution. So let's first look into the solution, the code, to understand the solution better. Okay, so here is the code. I've initialized the DP vector, DP array, and since n was max till 2000, so I've just analyzed the 3D array. This denotes the distance. This denotes the node. And let me zoom in a bit. Okay. Yeah. This denotes the distance, this denotes the node, and this denotes the parity. And this is just an adjacency list. So adjacency of I will store all the neighboring elements of I, right? And these are just the variables. N is the number of nodes, M is the number of vertices, K is the length of the distance, length of the path which we need from going from S to T, right? And X is the node which should have even parity. So yeah, first look at the main function. I took the input and initialize the dp with a -1, and for 0 to m I just created the adjacency list. So u and v have an edge, right? So adjacency of u is v and adjacent of v is u. And now just I call for DFS of 0, comma s, comma 0. This just means that starting from s, I need to go to t, right? And to reach s, I need a distance of 0. And the parity of x is 0 up till now, right? And let's look at the DFS function. The base case is simple. Say I have covered a distance of k. So that was the requirement in the question, right? And say I've reached t starting from s, I covered a distance of t or k and reached t, right? And the parity is 0. Like that's the ideal condition which we want. Then I return a 1, else I return a 0. And I've just memorized the solution. So if this is not equal to -1, that means we have already calculated the answer which is stored here. So I just return it. And now as far as the answer calculation part is concerned, so I just next is just the all the elements adjacent to node. I have reached node. Now I'll just traverse to next, right? So answer, I just start the number of ways. Now distance has increased by 1. I have reached here. And parity XOR this. This statement just says that if next was equal to x, this will return a 1, right? And say earlier parity was 0, means it had occurred even number of times. And say I XOR it with 1, then I will get a 1, right? Because this also says that x has occurred odd number of times. And say initially parity was 1, and now again this becomes true. Then again we do 1 XOR 1, which again gives 0, right? Because earlier I had odd number of times x, and again I got an x. So now x has become even number of times, right? And just at every step I do percentage modulo because the number of ways can be very large, and just return the answer and store it in this TP array. So I hope the solution was clear. And as far as time complexity is concerned, so it's simply, you can say, right, yeah, it's just dp of n comma right, the time complexity is n into k into 2, right? And so is the space complexity. Thank you for watching, guys. I'll link the code in the description, and if you have any doubts, you can mention it in the comment section. I'll try to answer them. Okay.